Hello. Here I'm going to talk you through two questions on vaccination. So straight away, starting with question one, just reading through. The graph shows the number of people with measles in the UK between 1940 and 2010. So the number of people with measles in thousands going up the side, and the year along the bottom. Part A, compare how effective introducing the measles vaccine was with the introducing the MMR vaccine. And it does say there, just draw your attention there, to use data from the graph. Okay, so any opportunity to use any of this data, then you should do that. So 3 marks up for grabs here. So the first point is looking at the measles introduced, there's the value there, and it is going up and down, but generally we're getting a fall. And the MMR vaccine is introduced at this point, and again we are getting a fall. It looks pretty much like it goes down to 0 despite the little spike there in about 1994. Okay, so what am I going to say there for my 3 marks? I'm going to say first of all that both the vaccinations lead to a reduction in number of people or number of cases of measles. Okay, so there's a pretty obvious first mark. The second point I think is the fact that the measles vaccine introduced a huge fall in the numbers compared to MMR, and if you could use the data there, that would be even better. So second mark, that the measles vaccine caused a large drop. Okay, and to get that data, I would put my ruler on there and I would read across nice and straight, and I would talk about how many thousands of people before the introduction of the vaccine, and then I would take a figure down here and indicate exactly how far it's gone. Whoop, and that has gone a bit squiffy. Never mind. So there's your second mark. For the third mark, you would say that the MMR vaccination pretty much wipes out measles. Or drops to 0. Oops, or drops to 0. Or you could simply say that it doesn't fall as much as the measles vaccine. Or once again, to use the figures, putting your ruler across to there, so we're coming up there around, what's that, 90,000 cases, and then I would state in 1995 it goes down, it looks like it's down to 0. So if you use the data, there's some easy marks there. Part B, the MMR vaccine was introduced in 1988. Other than measles, which 2 diseases does the MMR vaccine protect against? And you've just got to know this, and the clue is the fact that the M stands for measles, the next M would be for mumps, and the R is rubella. And instead of rubella, you could actually put German measles there as the answer. They would accept that in the mark scheme. Okay, part C is asking to immunize someone against measles, a small quantity of the inactive measles pathogen is injected into the body. Describe what happens in the body after immunization to stop a person catching measles in the future. Okay, so this is a 3 mark question, so they're looking for 3 points to get those full 3 marks. And the first term we're going to mention is the involvement of white blood cells. You could also use the term lymphocytes there, and that would be acceptable. So you mentioned the fact that white blood cells, for your second mark, produce antibodies. antibodies. Okay, not antigens, not antitoxins, not antibiotics. It is antibodies that they produce. And for your third mark, you need to say if that person gets reinfected or exposed to that disease for a second time, then the antibodies are produced very quickly, and it is that quick response that results in the disease being fought off incredibly quickly. Okay, question 2. People may be immunized against diseases using vaccines. Which part of the vaccine stimulates the body's defense system? And there's 2 marks up for grabs here. And what they're looking for is the fact that you're going to inject somebody with either a dead or a weakened you could also put there an inactive form of the pathogen, and if not pathogen, then that would read bacterium, virus or microorganism. What they wouldn't like is for you to put simply germs there. Okay, so a dead or weakened pathogen for the 2 marks. Part 2, a person has been vaccinated against measles. The person comes into contact with the measles pathogen. The person does not catch measles. Explain why. And there's 3 marks up for grabs there. So again, we're looking for 3 different points, 3 different reasons for us to be given the marks. So first point is that white blood cells produce antibodies. And I should also point out there for the second mark that they produce very quickly. So just that simple sentence will get you the 2 marks. And you need to say that the antibodies destroy the pathogen. Which is a very simplified description of what actually goes on, but that's all we need for GCSE level here. And part B, very long intro to the question with a graph, a very simple question there really, but we'll go through it. A man catches a disease. The man has not been immunized against this disease. A doctor gives the man a course of antibiotics. The graph shows how the number of live disease bacteria in the body changes when the man is taking antibiotics. So the number of live disease bacteria in billions. This is when the antibiotic starts, and it goes up to 5 days. Okay, so part 1 for 2 marks. 4 days after starting the course of antibiotics, the man feels well again. It is important that the man does not stop taking the antibiotics. Explain why, using information from the graph. So again, if you ever see that there, I mean, it is always wise to try and incorporate some information from the graph to demonstrate that you've actually looked at it and paid attention as you've been asked to. The answer itself is very simple. I mean, at day 4, you need to be saying about the fact that there is still live bacteria present, and if you could even put a number on that, that'd be even better. Okay, so you'd say the fact that there are live bacteria in the body. And those live bacteria, if you withdraw the antibiotics, then they're going to be free to reproduce. Okay, so you just say would reproduce. And that's all you would need for the 2 marks in this instance. Okay, the final part to question 2. Occasionally a new resistant strain of a pathogen appears. The new strain may spread rapidly. Explain why. 3 marks, so we're looking for 3 solid points to get those marks. So the first point I would make is that there is variation within the population, and that some of these will be resistant to the antibiotic. Okay, so there's your first mark. These will reproduce, and they will pass on their resistance to the next generation. Okay, so I would say the population of resistant bacteria or resistant pathogens, to use the correct term, increases. Okay, so there's your 3 marks.